Alright, in this video I'm going to talk about what is limit and how do we find a limit graphically, okay, by drawing a graph of a function. Okay, so what is the limit of the function? In last video we talked about what is the functional value. Functional value is the height of the function at a point at x equals to 1 or x equals 2 and so on. Okay, now the limit of a function is not exactly same as the functional value but close to that. Okay, so what does that mean? Meaning that for a function fx, if fx is a function, the limit of fx at x equals to a is the height of the function when x approaches to a. For example, suppose that this is the graph of a function, okay, fx. Now suppose there is a point A and you want to find limit at point A. So how do I find the limit at point A? The idea is you approach to A, so you get close to A from this direction and you can go close to A from this direction, right? You can get close to A from both directions. So when you get close to A, what is the height of the function? At this point the height is that, right? At this point the height is that. At this point height is this. And then similarly, if you get close to A from the right side, at this point height is this one. At this point height is that. At this point height is that. At this point height is that. Okay, so when you get close, very close to A from the left and the right side, did you see that? So the height of the function is close to that number L. Okay, suppose that height is L. Okay, this is x equals to 0, this is x-axis, this is y-axis. So when you approach to A from the left side and from the right side, if the height of the function approach to a number, if the height of the function is close to a number L, for example, L will be a number, A will be a number, okay, then we call L is the limit of the function fx at x equals to A. What we call is L is the limit of fx at x equals to A. That's what we call, okay? So again, so the function may or may not have height at x equals to A. The function may or may not have the value at x equals to A. For example, if the function has nothing at x equals to A, if there is a gap, let's say there is a gap there. At x equals to A, there is gap, there is break, okay? There is no, the function is not continuous. But still the limit can exist, okay? What does that mean? When you get close to A from the left side, you see that? When you get close to A from the left side, then you measure the height, okay? Get close to A, very close to A, very close to A, and then measure the height. And you go to A from the right side, measure the height at the closer and closer to A, and measure the height. You see that when you get very close to A from the left side and the right side, the height is almost equal to L from both sides, okay? So we call L is the limit of fx at x equals to A. You see that? Okay, now, so how do I write this? The notation for the limit is we call lim x, we call this as tends to, okay? So limit x tends to A, fx equals to L. This is how we write this one, okay? What we call, how do we read this? Is limit x tends to A, f of x is L. That's what we call. That's how we read this, okay? So limit x tends to A, fx equals to L. That means when x approach to A from either side, from left side or the right side, then the height of the function fx is almost equal to L, okay? That is called the limit of fx at x equals to A is L, okay? This is how we read it and this is how we write it, okay? So let us do an example by drawing, by making a table, by making a chart. So consider a function fx equals to x minus 7 over x squared minus 8x plus 7. Find the limit at x equals to 7. So how do I do that is, so basically we want to do we want to find the height of the function close to 7, right? So let us make a table, okay? I want to make a table and then see, suppose I want to make a table, horizontal table here. So this is x, this is fx. So I want to go to, basically I want to go to the 7, right? Let me put that 7 in the middle. I want to go to 7 from the left side and the right side, and then I want to check the height of the function, okay? Okay, so I want to check the height of the function close to 7, okay? So I want to check the height at 6.9, which is close to 7, right? I want to check the height at 6.99, which is also close to 7, also 6.999. I'm checking the height of the function at these points. These points are close to 7 from the left, right? And I want to check the height of the function close to 7 from the right as well. So I want to do 7.1, 7.01 and 7.001. These are the heights, right? These are the points that close to 7 from the left and right, okay? So what I do next is I will plug in 6.9 for x here and find the functional value at that 6.9, 6.99, 6.999 and so on. How do I do that? You can use calculator, okay? In the calculator, you can press y equals to and then press that x minus 7 divide by x squared minus 8x plus 7 and go to the table. You can go to the table, or you can do second and then trace and then value and plot 6.9 and then get the y value, okay? If you do that, you will get at 6.9 you will get, I get 0.1695, okay? So that is 0.1695. If I plot 6.99 for x here, what do I get is 0.1669, 0.1669, okay? And if I plot 6.999 here, then I'll get 0.1667, 0.1667 from the left, okay? Similarly at 7.1, meaning you plug in 7.1 for x, for this x, and that x, I will get 0.1639, 0.1639. If I plug 7.01, I'll get 0.1664, 0.1664. And at 7.001, I'll get 0.1666, 0.1666. So I don't have to worry about 7, okay? At 7, there may be one value or may not be a value. So no worries about that, okay? So you don't have to find out that one for the limit, okay? So I don't know how much is that. It may be a certain number or may not be any number there, okay? So basically the limit is the height of the function close to that point. Close to means close from the left, at the point close to the left, and then at the point close to the right of 7, okay? These are the height of the function. So we see that the limit here is, so limit x tends to 7, fx is equals to, you see that 0.1667, 0.166. If you round up to 3 decimal places, I get 0.167. That's what I get. You see that? I rounded up to 3 decimal places there. So when you round up, I got 0.16 and then 7. This is also 0.167. So this is the limit of this function at x equals to 7. Okay. So let us see another example. Find limit x tends to 0 and then sine x, 6 sine x over x, okay? So, but you want to find out limit at x equals to 0, okay? So, to do that, let me make a table again. So, how do I make the table? Let me make the horizontal table. So, x and then fx, right? And then what I do is I draw the line and make the chart. 2, 3, 4, 5, 6 values. I'm plugging in the 6 values there, okay? I can do 7 and then put 0 in the middle. I don't know how much at 0. I don't worry about that, okay? But I will take the values at close points to 0. What are the points close to 0? Because close to 0, some of the negative values and some of the positive values, right? So what I want to do is I want to try at negative 0.1, negative 0.01, negative 0.001, and then similarly I want to do 0.001 positive, 0.01, and then 0.1, and I want to check the height. Okay, so when I get close to 0 from either side, I will see the height, where the height of the function approaches. Okay, and then we will decide the limit after that. Okay, if I plug in negative 0.1 for 6 times sine x over x, what I do is I plug in 6 sine and negative 0.1 over negative 0.1, I will get 5.99. 5.99, okay, and the other will be 0. And then if I plug in negative 0.01, I will get 5.99999999. If I plug in negative 0.001, it will be like 6.00. That's what you will get. Okay, so we don't have to worry about this. How much would that be? No worries, because we will be checking the height only at the points close to 0. I'm sorry, close to 0. Okay, so not at 6, close to 0. From the left side, check the height. From the right side, check the height. All right, at 0.001, again you will get 6.00, and this will be 5.9999, and this will be 5.99. See, the height close to 0 from either side is 6. So how do I write that? Is limit x tends to 0, 6 sine x over x is equals to 6. This is the value of the limit. Okay, so the limit of this function at 0 is basically 6. Let us do this one using the graph. So this is slightly different because we didn't do the graph here. Now we're going to do the graph for this problem. Okay, so let us draw the graph of this problem. So if I draw the graph of that, this is what the graph looks like. Okay, so draw the x-axis and the y-axis. That is the x-axis and the y-axis. So how do I draw the graph? It is same as drawing the graph of y equals to 4 minus x, right? If I take x equals to 0, at x equals to 0, what is y? Y is 4, right? That is 1 point. And at x equals to 4, y is 0. That is, at x equals to 4, y is 0, right? You see that? So if you join these 2 points, so your goal is to find out the limit at x equals to 3. So 1, 2, 3. You see that? So how much is that value? That value is basically 1. So 1, 2, and then 3, and then 4. Okay. So you want to know the value of the function close to 3. You see that? So how do I find out that value of the height of the function close to 3? That means this is from the left. This is what it looks like, right? So from the left side, the height looks like this much. And from the right side, the height looks like this much, right? So what is that height? You see that? That height either side, from either side, the height is almost 1, right? So you can see that limit x tends to 3, 4 minus x is basically 1. You see that? You can guess the height from here too. You see that? So if you take the values of x close to 3 here, what do you get? At 3.1, it is 4 minus 3.1, right? That is 0.9. Similarly, if you take the values from the left side, it is 2.99. Let's say x equals 2.99 here. You will get 4 minus 2.99. 1.001. So 4 minus you will get 2.999 will be 1.001 and so on. So either side you will get, when you get very close to 3, the height of the function will be almost equals to 1. So the limit of this function using the graph is also 1.